This section's on perpendicular lines. When are two lines perpendicular? Whoa, what's all that? What a mess. Um, okay, I've got some lines sketched out here, and these two lines I'm considering to be perpendicular. They're at right angles. All right, and what we're going to do here is we're just going to kind of prove this. This is what we want to prove. Now, what is this? Well, M1 happens to be the slope of this line, and M2 happens to be the slope of this line down here. If you are given the slope of this line, then you can find the slope of this line by simply using this relationship. And this is what we're going to do to prove this. So we want to prove this. We're going to use the Pythagorean theorem, this equation up here, x squared plus y squared is equal to r squared. And we're going to use that to prove this. What we're going to do here is, if I know the distance of this side, and I know the distance of this side here, well, like this is going to be, for example, and I'm just saying that this is our x squared, okay, this distance, and then this distance here is going to be our y squared, and then when you square root it all, you should get the distance between here and here. But the first things first, and that is we must find this distance of this line right here. We need to find the distance, which I'm just labeling as D1. Well, to find this distance, you look at, use the distance formula, and you're going to look at the difference in x's. Well, we have 1 minus 0, which is 1, and we square it. So 1 minus 0 is 1, and 1 squared is 1, and that's where this number here is coming from. And then we're going to look at the difference in y's. So we have m1 minus 0, and m1 minus 0 is just m1, but then we square that and we get m1 squared. So we're using the distance formula, right, to find the distance between these 2 points here. Then we're going to do the same thing to find the distance between the origin and 1 comma m2. So you do the same thing. You look at the difference in their x's. Well, their difference is 1. And you square it. Well, 1 squared is just 1. So that's the reason I've got just 1 here, not 1 squared. And then plus, you look at the difference in y's. So m2 minus 0. And m2 minus 0 is just m2. And then that's squared. And then, of course, we must square root it. All right, now you notice that this is equal, this piece in here is D1, and D1 is being squared because we're plugging D1 into here. And then we're going to plug D2 into here and square it. Now that's what I've done here. All right, now before I work over here to R2 and find the distance, right, of the hypotenuse of this right triangle, I'm going to just simplify this left part out. And so when I square a square root, the square root just kind of goes away, and you're left with 1 plus m1 squared. And then we are doing the same thing over here. We're squaring a square root, so the square root just goes away, and we're left with 1 plus m2 squared. And then we want to simplify this down, so 1 plus 1 is 2. And that's about as simplified as we can get over here on the left hand side. Now let's look over here at the right. So back up to the diagram. So we want to find the distance of the hypotenuse basically of this triangle here, and we're going to look at the difference in our x's. So 1 minus 1 is 0, and 0 squared is just 0, plus then m1, right, minus m2. I think that's what I've got. Yeah, m1 minus m2, and then we square that. Now you notice we don't have 0 squared plus this. I just left the 0 part out. Now what we want to do is simplify this down. So I have to full this out, right? This is m1 minus m2 times m1 minus m2. Multiply all that out. Hopefully at this point you know how to do that. We're going to be left with m1 squared minus 2m1 m2 plus m2 squared. Right, m1 times m1 is m1 squared, m1 times m2, and then m2 times m1, and you get two of those, and they're minus, and then m2, negative m2 times negative m2 is just m2 squared. Okay, well, we can cancel some stuff out. m1 squareds cancel out. Okay, and m2s cancel out. And so now we're going to be left with this 2 here, and this piece over here, the negative 2 m1 m2. And then what we're going to do here is I'm going to divide both sides by negative 2 m2, cancel the 2's out, bring the negative to the top, and so you're left with negative 1 over m2 is equal to m1. So example, if m1 is equal to 5 and you plug it into this equation and you solve for m2, then you end up with negative 1/5. So it's just whatever this number is, right? 1 over this number, and then just make it the opposite sign of what it is. It's so it becomes negative 1/5. Okay, so let's say that you were asked to let's say that you were given the slope of a line, and I'll just kind of sketch something out here. Let's say that this slope is right, m is equal to 5, and it passes through, let's say this happens to be the point 1 1, and they're asking, well, find the equation to the line that passes through this point and is perpendicular to this line. Well, you are given the slope of this line, so you have that. You plug it into the formula there, that relationship, to find the slope of the perpendicular line, which is negative 1/5, and then use this point 1 1. Right, so just kind of sketching it out here. Okay, so this line passes through 1 1, and it has the slope of m2. So not too difficult to do.